This video tutorial will take a look at simplifying square roots. Let's take a look at a couple perfect squares. The square root of 25 is 5, because 5 times 5 is 25. The square root of 49 is 7, because 7 times 7 is 49. The square root of 4 is 2, because 2 times 2 is 4. All of the examples we have done to this point have been what are called perfect squares. A perfect square is when you take the square root of a number and it results in a whole number. Perfect squares are listed on the right side of the screen and will be left up as we will use them throughout this video tutorial. Let's take a look at the square root of 80. Our objective is going to be to simplify this square root. If you were to punch this into a calculator, the square root of 80, you would get an answer approximately of 8.94. Our objective is going to be not to find the exact decimal, but to simplify the square root. To simplify square roots, we need to break the square root down into the product of multiple square roots. In this example, the square root of 80 is equal to the square root of 16 times the square root of 5. We've highlighted the square root of 16 in red because when simplifying square roots, one of our square roots must be a perfect square. The square root of 16 is a perfect square. The square root of 16 is 4, and the square root of 5 cannot be simplified anymore because there are no perfect square factors in 5. So the square root of 5 is as simplified as it's going to be. So our final simplified version of the square root of 80 is 4 times the square root of 5. Let's take another look at how we could have gone about breaking this down. The square root of 80 could also be broken down into the square root of 4 times the square root of 20. And the square root of 4 is a perfect square. The square root of 4 simplifies to 2, but there is still a perfect square factor in the square root of 20. The square root of 20 could be broken down as the square root of 4 times the square root of 5, because the square root of 4 is a perfect square. So we have our original 2 multiplied by the square root of 4, which is 2, times the square root of 5, which cannot be simplified anymore because it contains no perfect square factors. So it stays as the square root of 5. 2 times 2 can be simplified to 4. And we are left with a final simplified answer of 4 times the square root of 5, which is the same answer that we got in our first attempt. Let's try another example. Let's simplify the square root of 63. The first question we must ask is if there are any perfect square factors. To the right, we see our perfect square factors, 1, 4, 9, 16, 25, and so on. 9 is a factor of 63. So we can break the square root of 63 down to the square root of 9 times the square root of 7. We want to use 9 because the square root of 9 is a perfect square. We can simplify the square root of 9 to 3 multiplied by the square root of 7, which is simplified because it contains no perfect square factors. So the square root of 7 remains the square root of 7. So the square root of 63 simplifies to 3 times the square root of 7. Let's try one more example. Let's simplify the square root of 150. Our first objective is to determine what perfect square factor goes into 150. We break the square root of 150 down into the square root of 25 times the square root of 6. We did this because the square root of 25 is a perfect square and can be simplified to 5. The square root of 6 is simplified because there are no perfect square factors, so it stays as the square root of 6. So the square root of 150 simplifies to 5 times the square root of 6.